Hi guys, welcome back to chemistry. Hope you've had a relaxing weekend and not getting too bored at home. I've got an update from the government today at 4 o'clock about what they're going to be doing about the alert levels. So who knows, maybe we'll be back to school some point in the future. So last week we were looking at Lewis diagrams. Today we are going to be looking at using these Lewis diagrams to work out the shapes of molecules. Excuse me. So to determine the shape of a molecule, first we have to draw the Lewis diagram. Here I have the Lewis diagram for water, H2O. We've done this before, but I'll just go over again how I worked out it looks like this. Oxygen has 6 valence electrons. That is 6 electrons in its outermost shell. You read out the periodic table. 4 of them are going to be in lone pairs, 1, 2, 3, 4. So we have 2 lone pairs, and then the other 2 free electrons or unbonded electrons are free to bond with the hydrogens here and here. So oxygen has 8 electrons around it, 1, 2, 3, 4, then 2 in each bond, 1, 2, 3, 4, so 8 in total, and each hydrogen has 2 electrons from the bond. To work out the shape, what we have to do is first count the number of regions of negative charge around the central atom. Oxygen is the central atom, it's in the middle, that should be obvious. And regions of negative charge can be either lone pairs or bonds. So here I have 2 lone pairs, 1, 2, and 2 bonds, 1, 2. So there are going to be 4 regions of negative charge around the central atom, 1, 2, 3, 4. Now we call them regions of negative charge because they are made from electrons, which are negative. Those are electrons, bonds are 2 electrons. And just like in a magnet, these electrons want to be, just like in a magnet, things of the same charge repel each other. So this area of negative charge wants to be as far away from all the other areas of negative charge as possible. So they are all repelling each other. Next, to work out the shape, we count the number of regions of negative charge which are bonding and which are non-bonding. So here we have 2 regions here which are lone pairs, not bonded to anything. So we have 2 non-bonding regions. And here we've got 2 bonding regions. So in water, there are 4 regions of negative charge in total, 2 are bonding and 2 are non-bonding. With that information, we should be able to work out what the shape is. Okay, so as each region of negative charge contains 2 electrons, they repel each other for maximum separation, allowing us to predict the shape of the molecule. So here is the first shape. It's called tetrahedral. I'm going to be using these pens to illustrate what shape tetrahedral is. Tetrahedral kind of looks like this. Give me a moment. So here we go. They are all as far apart from each other as they can. I'm going to like that, and they should be pretty much symmetrical. This is a tetrahedral shape. So I'm having a hard time with the camera. So this CH4 up here, this is the shape we get if all 4 regions of negative charge around the central atom are bonding. So this carbon has 4 bonds around it and no lone pairs. So that is going to be in a tetrahedral shape. Here, imagine you have a carbon on the end of each one of these, a hydrogen on the end of each one of these pens. These hydrogens want to be as far apart as possible, and this is the shape they form. It's called tetrahedral, and this angle here is called the bond angle between the 2 hydrogen carbon bonds. This is 109.5 degrees or 109 degrees. If you want to round it up or round it down. And this is called the bond angle, and it's important to know. If we look at these pictures up here, I have the same molecule, CH4, CH4. Here it's drawn just flat, and if we draw it like that, it might look like the molecule looks like something like this, just across, which, while it's easier to draw it that way, it's not accurate. It's actually drawn like this on the left in the tetrahedral arrangement I had before. Now, these two bonds here look fairly normal, but these bonds here, you can see one's got a dashed line and one's got a solid line. That means the dashed line means that is going into the page to show it's 3D, and this just shows it's going out of the page. So just to get a bit of three-dimensional perspective into the drawing, so we can see it's not just flat like this one on the right. So important thing to remember, 4 regions of negative charge around the central atom, it is tetrahedral. Now the next one is similar to tetrahedral, except it has 3 bonds around it. Here's my molecule again. 3 bonds around it, and then 1 non-bonding. So what we're going to get is it's going to be just like the tetrahedral one, same shape. It's really hard. Say it's the tetrahedral, but it has lost one of the bonding atoms. It's one at the top, we'll say, but the bottom of it stays the same. So you can see just the same as this one here, except it's missing that top atom. Yep. And instead it has a double bond, a lone pair. So if you draw your Lewis diagram, and it's got 4 regions of negative charge around it, 3 are bonding and 1 is non-bonding, the shape you're going to get is trigonal. It's called trigonal pyramidal, and it looks like this. Because it's exactly the same as tetrahedral, but missing 1 atom that goes here, it's going to have the same bond angle. So it's just got a bond angle of 109, just like the previous one. So see if I can hold these in a less stupid way. All right, so here is tetrahedral. We remove 1, we get this one, trigonal pyramidal. And if we move 1 more, we now get this shape. Bent. So this is the one we looked at with water. This is called bent 4 regions. So here we have 2 bonding atoms around the central atom. Here are 2 bonds, and then we've got 2 lone pairs. So if you draw your Lewis diagram, you get 4 regions of negative charge, and 2 are bonding and 2 are non-bonding. The shape you're going to get is called bent, like that. Basically, just like trigonal pyramidal, but missing 1 of the bonds. It's going to be 2 bonding, 2 non-bonding, and the bond angle will stay the same. So this is called bent 109 degrees, or you can say bent 4 regions, because there are 4 regions of negative charge around it. The next shape is called trigonal planar. This is what it may look like. It's flat, so you can draw it on one page without having to draw those in and out bonds. It's just flat, straight, and kind of in a triangular shape. So if you've got 3 regions of negative charge around the central atom, and they're all bonding, there's no non-bonding electrons around the central atom, the atoms or the bonds are going to separate for maximum distance apart and form this trigonal planar shape. If we have a look at this one on the right, we can see this carbon has a bond to this hydrogen, a bond to this hydrogen, and a double bond to the oxygen. That's just 3 regions of negative charge. A double bond is still just 1 region of negative charge. We've got 1, 2, 3, and they separate for maximum separation into this trigonal plane shape. Now, if we lose one, we get this shape. It's called bent 3 regions. It's just like the trigonal planar missing one. It's got 2 bonding regions, here, and 1 non-bonding region. 2 bonding, 1 non-bonding. Just like with trigonal planar, it's got a bond angle of 120. And down the bottom here, if you kind of don't get how these are formed, don't worry. We're not looking at these bent 3 regions very much in chemistry this year because they require something called dative bonding, which we're not really looking at. All you need to know is you see 3 areas of bonding around a central atom. 2 are non-bonding and 1 is bonding. You're going to have a bent 3 regions molecule. This may look similar to water or bent 4 regions, but with this one you've got 4 regions of negative charge and a bond angle of 109, while this one you've only got 1, 2, 3 regions of negative charge and the bond angle is slightly bigger at 120. Linear, straight line. Linear molecules happen when you have 2 regions of negative charge, 1, 2, or 1, 2, 1, 2, and no other regions of, and they're both bonding. So you've got 2 regions of negative charge and they're both bonding. The atoms on each side are going to want to be as far apart from each other as possible, these regions of negative charge, so they are a full 180 degrees apart. Also, if the molecule only has 2 atoms, like these ones up here, then it is also linear. So this is from the SciPad. It's looking at the 6 of the different types of shapes that you need to know. Tetrahedral, 4 regions of negative charge, all bonding. Trigonal planar, 3 regions of negative charge, all bonding. Then if we get tetrahedral and make one of the bonding ones non-bonding, it will become this, trigonal pyramidal. So you've got 4 regions of negative charge, 3 bonded, 1 non-bonded. If we remove 1 more, we're going to get this one, bent 4 regions, 2 bonded, 2 non-bonded. Here we have trigonal planar. This is the ones with 3 regions of negative charge around the atom. All regions are bonded. If we lose one of those atoms that have a lone pair instead, it's going to be this bent 3 region. And here's linear, where you've just got 2 regions of negative charge and they are both bonding. Like always, there are exceptions to these. Well, when you're trying to draw these shapes, there are some weird atoms which do things a bit differently. So the exceptions for this are beryllium and boron. They are molecules, they are atoms number 4 and 5 on the periodic table. They are non-metals, they do form molecules. But they don't have very many electrons in their outer shell. So beryllium and boron only have 2 and 3 valence electrons respectively. This means they will have less than a full octet in their valence shell. Beryllium has 2 valence electrons, so it forms 2 bonds. So it's going to form, so here we have beryllium chloride. It's going to share an electron with chlorine. Chlorine is going to get 1, 2, 3, 4, 5, 6, 7, 8 electrons. And it's going to share an electron with this chlorine, 1, 2, 3, 4, 5, 6, 7, 8. So both of the chlorines have 8 electrons, but beryllium's only got 1, 2, 3, 4 valence electrons. So, so it doesn't have a full shell, but it is still stable. It's an exception. It only needs 4 in its outer shell to be stable. Boron's very similar, except it's got 3 valence electrons, it's going to form 3 bonds, and that means we'll only have 6 electrons in its valence shell. These are just exceptions you need to remember. They do ask them from time to time. But we're going to leave it at that for today, and I'm going to tell you what work you will be doing in SciPad. So, what I want you to do on the SciPad is read page 48. It's just what I've been doing. It explains how to draw the shapes of molecules. So, this bond here means the bond is coming outwards of the page, and this bond here means it's going into the page. I'll show you the top one. There we go. For this exercise, you are going to draw the Lewis diagram of CH4 first. Say what shape it is by counting how many regions of negative charge are around it and if they're bonded or non-bonded. Work out the bond angle, that's going to be listed here, and then draw the 3D sketch, that's this one here. So for CH4, that's what it's going to look like. Make sure for your 3D sketch, if you need to have bonds coming out of the page, they look like that, and going into the page, they look like that. There are actually only two shapes that need to be drawn 3D, and they are these first two here. Cool, I'll just show them. So tetrahedral, that one on the right there, can't make it go away. CH4, just like that, and trigonal pyramidal also needs to be drawn with the bonds going into and out of the page. Basically just the same as CH4, except it hasn't got that bond on the top. It's got a lone pair instead. So if you can do those page 49 and 50, it's just very repetitive stuff. What's that one there? SO2. SO2, if you cannot do SO2, that is completely normal. That one should not be in the book. It requires dative bonding. You can try work out how to do it, but if you can't do it, then that's normal. I haven't told you how to do it yet. And then go across the page and do page 51. It's got a little bit of things about beryllium and boron down the bottom. So yeah, we'll leave it at that today, up to page 51. And remember, if you've got any questions, ask me. Or send me an email or something. Cool. All right, that's all for today. And I'll send you another lesson tomorrow sometime. See you.